Hello and welcome to part 2 of my conversation with Mathew Barnett Howland. This is episode 110 of the Building Sustainability Podcast. I'm Jeffrey Hart, and every fortnight join me as I talk to designers, builders, makers, dreamers and doers. Together we can explore the wide world of sustainability in the built environment by talking to wonderful people who are doing excellent things. So we're going to dive straight back into part 2 of this conversation with Mathew. If you haven't heard part 1, then definitely start there. We are talking about Cork House while sat on the sofas in Cork House. This conversation was in the making for quite a while. When I was researching the use of cork on my own house, Mathew's work kept popping up. And so I was thrilled when he invited me to see Cork House in person and record the episode there. Right, that's it. Straight in. I'm back at the end. Enjoy Mathew Barnett Howland. This is going to be a drastic swerve back into material.
Good, about time.
So I saw at the Waste Age exhibition.
Yeah.
I saw there was a little video. I think it was something to do with this house. It was certainly Amarin. But they showed a robotic arm.
Oh yeah, the machining thing. Yeah,
like the sort of,
that's right,
ones that build cars. That sort of
multi-angle. The KUKA robot.
Yeah,
at
just
Bartlett,
whizzing round and
speed it up. Yeah.
Oh, was it okay? Because I when I used this stuff, I wanted to get. They called it shiplapped. I think was a product on the website.
That's right.
And I wanted that as a sort of stopping water tracking in, but couldn't find anyone to sell it to me. So I made my own with a router table and spent days putting it through. Yeah. And it machines remarkably well.
Isn't it?
Yeah, a router and
how nice is it to work with?
Yeah, and the granules, the little fine granules that come out were just compost.
Yeah, that's right.
Brilliant. How much is there sort of an interlocking? That's a sort of strange way into that question. Are these blocks sort of sculpted to be? They're more than just a slab.
Yeah, machining. Yeah, good question.
Feels quite odd to drag it back to.
Yes. No, well, that's in a weird way. It's not. It's not unconnected.
Okay.
To that story. Because in terms of this lovely material with this nice backstory, and in terms of preserving its nature until after the, when it stops being a building again in future, it obviously relies upon disassembly or relatively easy / economic disassembly. And one of the key factors there obviously is not sticking things together with glue and mortar. And one of the ways of doing that obviously is through dry jointed construction, a bit like dry stone wall or even the ancient corbelled tomb structures that were made without glue or mortar. And the way of achieving that, in this instance, at the same time as meeting contemporary building regulations, was to use the digital technology, in that instance, the KUKA robot, to achieve that nice, snug, friction fit interlocking system. Mm-hmm. So yes, it's a tongue and groove system with no offset in the tool paths. So by which I mean that the block below is machined exactly as the negative of the block above, or vice versa, which gives you this really nice friction fit, which we did initially just through a router. Like you. There's quite a lot of hand tooling in the first couple of prototypes and so on, and it's a really nice fit. It almost sort of it sort of it sucks. It's nice. And what did that really give us in terms of? I guess it gives you just a nice tight structural interlocking fit. Obviously, you don't really want a wobble built into it. I don't think it really did much more than that in terms of air tightness. So, I mean, obviously, it will have contributed a bit to the air tightness. But then if you're relying on a dry jointed system, there are always going to be places in the construction as a whole where that isn't a totally perfect friction fit.
Yeah.
Or interference fit is what they call it in the machine world.
As in, it's just touching enough to create a bit of friction.
Yeah. So it was a really lovely thing to work with, and I did most of the prototypes by hand, like you did, and then it got to the point where we were, although it sounds like a nice simple idea, blocks of cork equals wall, or equals roof, that material simplicity actually ended up, in order to function really as a proper piece of wall or roof, ended up quite complex geometry to each of the blocks, with the tongue and the groove. And obviously you get corner blocks, half blocks for windows, eaves blocks, and then the roof as it corbels in. I can't tell you how many block types that generates. And obviously offsetting creates quite a lot of complexity, because obviously in the wall it's relatively straightforward, which you could probably do on a router, just push it through a spindle molder, get an easy tongue and groove, but when you start offsetting, obviously your tongue and groove don't line up above and below.
Of course,
and then corners. And then we had all these extra grooves for water management, which I'll come back to in a minute, because it is a red herring and was a red herring in the research. Anyway, because the way I'm going to with this is the complexity in those roof blocks you just couldn't do by hand with any level of accuracy, or if you did, it would take you 4 hours a block. So the Bartlett has got relatively very good robotics department in the workshop there. This was about, again, 8 years ago now. And so the guy who runs the workshop there, or used to run the B-Made, which is the fabrication facility there, Peter Scully, he was really useful and helpful in taking that hand analog technology into the digital world. Then obviously you're into tool paths, and so whether it's Rhino or SolidWorks, and how that connects into toolpath software. That's for the research, it was done on the KUKA robot using Rhino and Grasshopper to drive the toolpaths, and that was good enough for the little test cabin we made, which was sort of proof of concept halfway through the research. And then we realized that then in the next step up, we realized that form of digital fabrication was one block at a time. KUKA robots are not really ideal for making that sort of very accurate orthogonal geometry on that sort of scale. So we went to a 5-axis CNC machine workshop called Doodle in Suffolk, and because the house is 1,300 blocks.
Right.
And it just made sense to go slightly more commercial with that. And then he turned out to be a really interesting character who I'm still very good friends with, and we're still working with him on the other Cork type projects. But it's a hell of an undertaking for him, because they're quite big. Because you're machining them on their side, you've got quite a big Z-axis. There aren't that many workshops that do that scale of Z-axis on a 5-axis CNC. Most of it's done more with the scale of sort of steel engineering and so on, smaller scale components. And it was hugely messy and loads of dust, and they had to get huge extraction systems on. Anyway, that's how we delivered the house. So he would make about 25, 30 blocks in a batch, deliver them here in a van, while I was going around making sort of building at the house up course by course
Yeah.
in a kind of Lego type way. Each course had a little diagram with block numbers, and I'd have to sort them out, and then set them up around the edge of the CLT slab, with a big scaffolding cover to keep the whole place dry.
Yeah.
And then it was really nice. Once you got into the swing of it, it was relatively straightforward. You lay all the blocks out, and then at the end of the day, you can just go around and they literally would just go 10, 15 seconds a block.
Yeah.
Oh, it's rather lovely, yeah.
Yeah.
But obviously, I don't want to give you the wrong impression that it was that it was all.
You were having a lovely time the whole time.
Yeah, exactly. So the machining, because it's about 18 meters long, the building, and then so you're relying upon the last block that goes in on each course has to be a double female, as it were. Because you can't get that last block in, so it has to come from above. And that last, if you're going to get an interference fit, you're asking the building to be 0.5 millimeter accurate over 18 meters or so. And occasionally it was great. Occasionally it sort of slide in and you go, yeah. And then occasionally, oh man, here we go. And you get the old hand tools out and off you go.
Right.
Butchering it. And,
yeah. How long did it actually take to build?
Don't know really. We always, when I look back at it, I had another guy helping me who lived on site, and we think it took us about a year between the two of us if we were working full time every week. We reckon about a year for two people.
I guess, that's for a building of this size, it's quite efficient.
Yeah, foundations, services, finishes, it's all right.
I suppose my house took 18 months of just me.
Yeah, but that's part. But if you condensed it all.
Yeah.
But it doesn't feel, and obviously the self-build was a huge part of it, a huge motivation, which, that isn't something really that I talk that much about, but that, as I said, going back to, I like being physical and outdoors, and so that was a real motivation to do that. I wanted not to go back into conventional practice.
Yeah. Was so you said that the guy dropped off 25 blocks at a time.
Yeah.
How quick was he sort of producing them?
Yeah, pretty quick. I had Thames allowed me to use their site just here and had a hole in the fence, and so I stored them all in this big, and often obviously the block you'd want, as you can imagine, is deep down at the bottom of the pile.
Yeah.
They need to cover them up, and I had sort of huge tarpaulins, like 20 meters long. Yeah, and that was quite logistics, isn't it? Just logistics.
Yeah.
It was quite funny because until you get to the eaves and you lock the whole structure together with this timber ladder at the eaves, which there is, a timber grid, if you like, in plan, the house is pretty movable feast, really, because there's no mortar or glue, So it wants, but it can move longitudinally, laterally, diagonally, when the wind blows,
Yeah.
So there was an interesting phase where when I built the walls, nothing's holding it in place, the ladder goes on, and then just getting the walls into the millimeter perfect position so that the ladder, which is prefabricated as well, would fit. And then once you bolted and nailed and screwed all that down, then the house becomes a kind of thing, a fixed structure. So all the beams and ring beam, valley beams, CLT wardrobes and stuff, they're all prefabricated in Estonia. Strangely, just got a really good deal from someone. So ordered them direct from the mill. So that was an interesting discipline. Was everything, which I've not done before. Everything being drawn, so breaking the building down, I guess, from the architectural thing, breaking it down into components, and then sending those off to some workshop somewhere, whether it's the Cork or the timber or the doors and windows, and understanding all those processes enough to send those drawings off as fabrication drawings. and then getting them sent direct back to me, not to a warehouse or via a company or anything like that. Yeah. So as I say, going back to that materials idea, that was a really lovely thing as well. Actually, that was a really nice discipline.
Yeah.
Yeah. Yeah, doors and windows, they were fantastic. They've got a really fantastic joiner, prototype them with me. Because if you, again, you won't come across this, but when you open they're a bit like a Velvac, so that the opening frame shuts onto the fixed frame, so you don't get a double thickness or an offset.
Yeah.
But that's really hard to achieve if the outside bit is also timber. And Velvac do it by having the outside bit being aluminium.
Oh, I see. Yeah.
Anyway, that was nice. So all the doors and windows are totally bespoke as well. And that's quite something, because, just understanding, it makes you think a lot about, when you're doing things from first principle, about water and air pressure and drainage and how it really works. And actually the doors and windows are probably, when one of the RBA judges came, that was the thing she was most interested in. So, she said you should really think about those doors and windows. Yeah, never mind the Cork stuff. Yeah. In terms of scalability.
Yeah,
and they are really successful. Yeah, they're a Koya, super stable, good longevity. I think those are probably the most successful thing to come out of it in the long term. Yeah. Oh, going back, that's right. So with the Cork, that was interesting. So yes, we had all these extra grooves and things. Again, so it became like what Oliver and I were looking at with the doors and windows in terms of understanding pressure and water. We sort of looked at that at the scale of the whole wall and roof in terms of how do you design a block system that's dry jointed, so water's going to come in. No? You can't stop that.
Yeah,
it's going to come in through those joints, and how do you then control the water into grooves, vertical, some of them which are vertical if it's on a perpendicular during the perp, and then catch that water in a groove, take it down into a horizontal groove in the block below, and then feed that out into a groove that exits. Yeah? So it's
sort of a little internal gutter.
A water management facade.
Ooh, that's fancy.
And actually, weirdly, so the reason it doesn't work, and the reason it was a huge waste of time and effort and money, probably about 10 grand's worth of machining down the drain, literally actually, it's because obviously Cork's like a sponge, huh? Because it's reconstituted material. So it's permeable. Right. So the water just comes, it's like designing grooves in a sponge cake or something. It's pointless, no? If you pour a hose onto a sponge cake, it's wet.
Yeah.
Doesn't matter how many grooves you put in it. So we designed that system works if the material itself is impermeable. It's actually a very clever system.
Yeah.
If we had a technology that made magical impermeable cork blocks using a water resistant binder, and so the blocks were sort of big, the impermeable units, then it's a great system.
Yeah.
Which honestly, when we did it on the prototype, it was like, because it's a double thing as well, double lock. So where the tongue fits into the groove in plan, you've got an opportunity at the front of that joint to catch the water. And then if the water somehow managed to get through to the back, we've got another one there that goes into this double groove in plan, and then it all feeds back out. Honestly, we were like, we did it, we were like, come on, that's pretty bloody good. Come on, Olivina. We're like high-fiving. And then we did the water testing. It came out of these grooves, and we're like, fuck, that's so clever, man. And then over the space of sort of 6 months, while the prototype eventually started to leak.
Right.
Because it was just a big sponge cake.
Was this the
cabin? Yeah.
Yeah.
And we thought, that's not worked, has it? And then we went back to how the cork is made. So when it comes out of the pressure cookers, it's this big steaming, it's a brilliant looking thing. I've got great videos of it. It's like a sort of like a spaceship as it comes out there with smoke going everywhere. It smells amazing, and the heat. And it goes into this chamber, and about 50 hollow needles get shoved into the top of it, which impregnate water deep into its heart of the cooking block to stop it cooking. Otherwise, it keeps on cooking and burns.
Okay.
Which is a disaster.
Yeah.
And as it does this, all the water comes piling out of the sides of the block. Yeah. So we'd been to the factory, watched this happen. Yeah. What does that tell you, though? It tells you that the block is permeable, doesn't it?
Yeah.
So honestly, one day we went, hang on a minute, Oliver, remember that video? You got the video out. Oh man. Anyway, so then we had to reassess how those blocks performed, and that they were not just breathable, but also over a long period of time in the roof, particularly where you're catching water vertically on an inclined surface. That eventually, over a number of months, that will come through unless you put some kind of jacket on the roof.
Right.
The walls, I'm happy with. The walls the walls are like a brick wall.
Yeah.
That's what it's like. And it's like making a clay brick, like a Georgian house. If you made a roof out of cooled clay bricks, eventually it would leak. Like in all vaults around London that are brick built underneath roads, they're all soggy.
Yes.
Yeah, because over time that percolates through. So yeah, that was explaining why all that super smart ass channels and things, but it was anyway. Yeah.
So the walls are just solid. I say just solid.
Yeah, so they'll get wet about. We reckon we did some tests after that about 2 or 3 inches into their depth. And then we'll dry out. Yeah, because I haven't got any membranes in there, or that's where the monolithic nature helps you out.
Yeah,
like it would on a solid brick wall.
Yeah, and then, so the wind blows and draws away that.
Dries it out, and also obviously it's important that it's occupied like a brick house. And if you go into a brick house that has been occupied for 10 years, they're damp and mouldy, especially on north faces. It's a much more living, interactive kind of relationship to the environment those buildings have.
Yeah. Yes.
They do really, that whole concept of breathability, and that often confuses people in terms of air tightness.
Yes.
And in terms of permeability, they're all slightly different concepts. Yeah.
Mm-hmm. We've talked about that quite a lot.
Yeah.
What was I going to ask you then?
I'm exhausted there, actually.
Oh, sorry. You're doing fantastic, by the way. This is great.
I think it was that stuff about death as it actually finished me off.
You might get the first room.
Yeah. Hastened it. Yeah, assembly. So just going through this life cycle. So we did the cork, done the fabrication. We mustn't forget the transport as a life cycle thing, because it's a Portuguese material. Well, it's Mediterranean material.
Yeah.
It's obviously going to have quite a lot of transport carbon emissions associated with it.
Yes.
And just to give you an idea, about half of the tonnage, it was tonnage in the end, of sequestered carbon in the fabric of the house is offset in the transport.
Right. Have you got sort of numbers for that? No is an acceptable answer.
I think it was around 30,000 kilograms. So let's got 30 tons.
Right.
So I guess around
of sequestered.
Yeah.
In the whole building.
In the cork.
Yeah.
And about 15 tons in transport, I think.
Right.
We had a whole life carbon assessment done by Simon Sturgis. You've probably come across, who now his organisation is called Targeting Zero. At the time, it was a carbon assessment business, which no longer exists. And at the time, it was quite a long time ago. When was that? 2017, so 6 years ago, maybe 5-6 years ago. We were having those assessments done. My knowledge wasn't what it is now. And the industry's probably wasn't, and we didn't massively interrogate it, but it was a whole life carbon assessment according to BS110 which is the RICS methodology, also adopted by RBA and so on, and also relates to a European standard as well. And that did show it was the lowest whole life carbon assessment they'd ever assessed, and particularly embodied carbon was very low, let's say, compared to the model reference projects that they were using at the time, and which obviously would be those reference projects will have significantly improved since then.
Yes.
So we've got material origins, how it's made in the factory, then it's transported, quite a lot of carbon, then it goes to the workshop in Suffolk, Doodle, where it's machined, which obviously also uses embodied carbon. Then it's brought down here, more transport, packaging, which often isn't talked about.
Yes, I've talked about it quite a lot recently. It's one of my bugbears.
Bugbears, yeah. So that came on pallets, which I couldn't get anyone to take off my hands at the end of the project. No one interested. 50 pallets or something, maybe more. Wrapped in that cellophane that holds things together really beautifully in transport. But what do you do with that?
Yeah.
One nice part of that is that the waste from the machining, Richard found a way of compressing it into briquettes, little elephant poos they look like. And then he uses that still, I think, to heat his massive workshops up there.
Brilliant.
Yeah. Brilliant for him. I've paid for that. No, sorry. Not only have I paid for it to buy the cork, I then paid for him to machine it. And then he gets the heat his workshop. Anyway. He's a very good friend as a result. So that's the packaging. Then the assembly process, which, as I say, is a rather, that again was a very satisfying, another pretty successful part of the thesis, in that it was, generally speaking, rather nice thing to build. Quite sort of caveman-y, primitive.
Your toolkit for the day must have been pretty sort of...
Hand tools generally.
Yeah.
Nothing major. Maybe a chop saw, maybe electric planer, a router, the usuals, and a general multi-tool for those bad moments when two blocks refusing to fit. Yeah. And obviously, and then just a cordless drill. By and large, because everything is either done by friction, placed in position by hand, or it's mechanically fixed using bolts wherever possible, and if not, then screws. So bolts for the doors and the windows, those bolts I was describing earlier for the lateral structure, brass screws for the floorboards, furniture screwed together, everything pops out, everything's accessible, no hidden fixings. Roof is assembled without formwork, which is unusual, vaulted structures generally require false work.
I see, yes.
This was quite an interesting way of doing it, this kind of form of construction, the corbel, which obviously predates vaults and voussoirs and so on. So as you build up 3 or 4 courses and it starts to come inboard, as you walk around on that, when you get to about the 3rd or 4th course up, obviously it starts to give. Obviously there's a limit to which point you might drop in. So that's why when you look up here, every 4th course,
I see.
You see a minor ring beam, we called it. It's about 150 by 50, so 6 by 2 on its side. Because obviously the problem isn't vertical load, it's lateral load with cork. Because it's weak in that direction. So that would stiffen it up. So it would geometrically would help you set the roof out. It would hold it sort of in the right kind of dimension. So then the blocks would keep working, as it were. It meant you could walk around. So it's almost like built-in sacrificial
integrated scaffold.
Yeah. And then you build 4 more, another one, 4 more, and then the roof light, which is again is the timber frame that holds it true, and then you drop the roof lights on. And then so the roof lights and the foundation, the screw pile foundations and the CLT floor, those 3 things are where I had help from a friendly local builder
Yeah.
with a telehandler and a massive Polish bloke to help me lift things into place.
Yeah.
And I mean just giant. So that otherwise it was just done, very light technology, and that was really lovely thing. Which again, don't think was totally thought through at the outset.
Had you already sussed out the sort of integrated scaffolding on your test build?
That happened on the test one, on the cabin. Again, that happened working, partly through us working with the material and doing test structures, but also working with Arup, who were fantastic. Two brilliant engineers. Arup, who were timber specialists, and they were great. They were part of the research team and part of the engineering team for the house itself. Yes, that was assembly. What else was there? Yeah, the only real challenge I said during the assembly was fixing the house into its shape. When you move from the wall to the roof, it's a big moment. I had to make a very elaborate clamping system with these quite Heath Robinson ratchet straps. I've had, like literally about 20 ratchet straps, about 30 meters long, going around the walls and I had to make end clamps.
Yeah.
So otherwise it would destroy the cork. So these big reinforced timber end clamps. Quite a lovely set of things they were. And you'd ratchet it up, so putting God knows how many tons of pressure through all the walls, longitudinally through the walls, if that makes sense.
Yeah.
To kind of get it into position. Yeah, and then you could drop in the ring beam, and then life was good.
Just drop in the ring beam.
Yeah, that was relatively easy, because then that was all prefab, so you just had,
So it just had to be exactly.
Yeah, and it's just screw. There are some screwed down metal plates making the connections in there, but again, those would be accessible. So the point about the false work is that, therefore, when you're disassembling the building, it's quite uneconomic to have to rebuild a load of temporary false work, which is what you would do for a vaulted building. So here, you go up, you take the roof light off, take down the blocks, take off that minor ring beam, unscrew them at the corners, only 2 screws each corner, take those off, then go you all the way down, and you get to the eaves, you take off the 6 metal plates that are in the ring beam, which are now accessible, take those off, ring beams come back out as parts, you take the valley beams off. The valley beams are the beams that run between the pyramids. And then the same for the walls, down to the base, windows and doors pop out very easily. Like I say, 6 bolts, 10 minutes. Even these CLT wardrobes, these structural wardrobes, which is what the ladder beam is tied down to for the lateral loading. So these are working in that direction laterally. Those you can see, so everything's expressed and accessible. So those undo. Floorboards unscrew. Again, the CLT panels unscrew. They're lap jointed with the CLT screws. They come out. Lift those out of the Akoya ring beam around the edge, which is just a 300 by 100 beam with a ledger beam screwed into it, which the ledger beam is just an extra batten at the bottom of the beam that the CLT sits on through gravity. So lift out the CLT, unbolt the sections of Akoya ring beam, which go from screw pile to screw pile, so about 3.6 meters span each one. So I don't know what that is. Let's call it 20 bits of beam. And then the screw piles come out.
Yeah.
And then you're left with a garden. Gone. Nothing. Gone. Just left back to pure garden. Cork House was never here. And all those materials, in theory, have been relatively easy to recover or reclaim, let's call it, is a more conventional word. So it's reclaim. Now, whether those materials genuinely are reusable is a more complex question.
Like, could you take them and build a structure elsewhere?
Yeah, because the circular economy, one of the key words there, apart from the idea of the circle, is the word economy there. So is there really an economy of cork bricks out there? No, not unless you turn it into a scalable thing. And then at what point does a system really become a platform across an industry. I mean, the world's supposed to be a simple place, but we have Apple and Microsoft, which don't talk very well to each other.
Yeah.
And actually, the best material for the circular economy is as old as the hills, isn't it? Which is a brick, with lime mortar. What's not to like about that?
Yeah.
Totally reusable. Everyone understands it. It's in between a material and a product. It's a really interesting thing, isn't it? And if it's lime mortar, clean the mortar off. I built a house about 30 years ago. My first house for myself was made with reused bricks, London stocks. Tragically, at the time, because I was an idiot, I used cement-based mortar, which still most people use.
Yeah, so it couldn't be reused again.
Yeah. We're doing a house at the moment that's made entirely with reused stone and brick from a demolished house on the site that we're reclaiming. And that's possible because it's a Victorian house made with lime mortar. And obviously, over time, they probably degrade a bit and lose their arises, and probably limit to how many times you can do that. But and then there's a lot of problem. People have a lot of issues with the embodied carbon that goes into firing bricks, or at least the timber brigade do. Sly use of the word brigade there. There's a lot to be said for that.
Yeah.
It's fired, but it still goes back to in 1,000 years when that starts to break apart. That still goes back into a dust which I imagine can go back into the pedosphere from where it came from. The clay strata. But it's got a lot. It's got a lot of building lifespans in that. Yeah, well, interesting conversation there, isn't it? About
you were deconstructing the building.
So I think I've deconstructed it. Yeah.
While you were doing that, I was sort of mentally wondering, how long it would take to sort of verbally deconstruct, a conventional building.
Yeah.
Yeah.
Well, could you?
Well, exactly. There's so many.
You get stuck, wouldn't you?
Yeah.
When you got your plaster skim on top of plasterboard with scrim tape, and foil on the back of it with black screws fitted into a maybe aluminium metal stud or steel stud. So talk me through that one. Yeah.
Cork and fire. But there's these beautiful sprinkler systems within your building, copper pipes.
Yeah.
How flammable is cork?
It's Euroclass E. Well, that's what we were dealing with at the time. I know now, since leaving the EU, we now have to talk in terms of UK fire. But at the time, it was a European material with a European partner, and they were cross-platform. So we called it Euroclass E, which essentially means it's pretty rubbish.
So A would be non-flammable.
Yeah, concrete.
Right.
For example.
Yeah.
It's difficult because I don't like talking about materials, the fire performance of materials in isolation from how they perform in situ as a building.
Yep.
Because it is a complex interaction to do with compartmentation, escape routes, sprinkler systems, spread of fire, fire integrity or structural performance during fire. So it's complicated, but I think that's a really important thing we had a fire engineer on this that was Arab again. So in order to meet building regulations with where this building sits in relation to the boundary and the layout of the house and the nature of the material and the nature of the fire suppression and detection system, it meets building regulations.
Yeah.
Does that mean that cork is an sensible or easy material to use in relation to fire? Probably not. So, yeah.
Because it's I mentioned this earlier. I was at a trade show where someone was selling cork, and they said, of course, cork is non-flammable. And I thought that's nonsense, because I've been using offcuts in my wood burner to start my fires. I know very well that's not true.
So we did a fire test, a proper BRE fire test to the relevant BS during the research process for the roof, the performance of the roof, which is a roof classification, which is AA, AB, AC, and so on. We had to achieve, I think, in A, B. Anyway, we achieved it in terms of the spread of flame and the integrity and fire penetration, if you like. And yes, there was some charring, as you'd expect. And over the course of the test, we lost about 60, 70 millimeters of the thickness of the material, but that's okay because it's very thick. So it still worked as a structure, but that is meeting a very specific set of performance requirements in relation to regulations that relate to roofs, which is a certain temperature, a certain distance of the fire panel in the test from that surface, how long it burns for. So when it comes to walls, we didn't do, because I didn't need to fully understand or do the fire test for load-bearing walls. So in a single-story building, you need to understand how the roof performs, but you don't need to understand necessarily how the walls perform. And in terms of fire, there are lots of routes out from this, and it's got sprinklers and it meets necessary regulations through fire engineering. But I'm pretty certain that I know that wall tests are more demanding, as one would expect, if you're going to start building multi-story buildings out of it. So it's complicated,
yeah.
But it's like, I know there's all sorts of discussions, should we call them, going on across the industry about building in timber and building in timber at height.
Yes.
The magic 18 meters and 11 meters and so on. But yeah, it's a combustible material, so proceed with caution. I think the same with tall buildings.
Yes.
I'm not saying that one shouldn't make tall buildings using timber, using CLT mass timber, but got to be sensible about it. The people I know that we worked with in Edinburgh originally, who did some characterization of the material rather than the full BRE testing. I watched some of their where they comment on some of the industry discussions going on, and they're very, when you listen to fire engineers, they're, well, as you'd hope, very sensible.
Yes,
and circumspect about some of the what should we say, claims that are made by some parties in some situations, as you say, in trade shows or hot topic, as it were. Yeah, it's a difficult one. I mean, then the question of building high in any material probably is interesting.
Yeah.
Yeah, never mind whether it's combustible material or not.
Well, yes.
I mean, you've still got people at height, haven't you? A long way from escape, let's call it. Unless it's a stay in place strategy, you've still got people a long way, and that's pretty tough stuff, isn't it?
Yes, I don't think I'd want the job of specifying that.
No. Nor do we. I'm not sure I'd ever want to go there. Really, I think the mid-rise is a nice place to hover in terms of one's interest architecturally for urban reasons and so on. Yeah. I'm not a massive fan of any high-rise really. So I suppose that makes my position on fire quite easy, really.
Yeah.
Don't do it. Don't go high. Yeah.
Insulation-wise, obviously Cork is
Mm.
an insulator.
Mm.
It sounds like you made the wall thickness based on kind of the material
Yeah.
thickness.
Sort of, and stability, and yeah.
Yeah. Do you how much insulation do you have?
Yeah, it's in the walls. I think it's about 0.1.
Okay.
Yeah.
And then does it change in the?
Changes a bit in the roof because you've got slightly fatter and thinner moments in the profile.
Mm.
So it's about 0.13, I think.
Okay, it's good though.
It's good, but it's quite a lot of material.
Yep.
So then you get to that kind of, it's that again going, is it more intelligent to use different materials for functions that they're really good at?
Mm-hmm.
3 or 4 materials, maybe one for structure, one for insulation, and of course there's a good argument for that.
Yeah.
It'd be idiotic if I didn't acknowledge that. But there are some benefits in terms of building life cycle in using a single monolithic material and making things simple. So that's what's interesting about the building life cycle as an approach, the whole life approach, as I called it. Again, it's really useful when you're teaching as well. It's a really good overarching framework for having an intelligent, nuanced conversation about buildings and where some decisions work really well, and maybe those decisions don't work so well in other places in the building life cycle. And it's no magic bullet. No one's out. I don't know of any system yet that nails every single thing, and is brilliant in terms of performance and cost and scalability and disassemblable, So that's where I think that's a really useful framework for thinking about buildings and design process.
Yeah.
Yeah. Balanced decision making. Yeah.
So I think just sort of wrapping up, I guess.
Yeah.
First of all, is there anything that you particularly feel like you want to say?
I'm particularly interested in the richness of the material, spatial, embodied experience that a building is, which is why I wanted you to do this podcast in the building. That's what we discussed, wasn't it? I didn't want it to be another sort of press interaction, or press, but you know what I mean?
Yes.
Yeah. In interaction with another external party that was in the abstract, that became about sustainability or any of the ideas we've discussed, not in the context of the thing itself, and of the experience, and of of what that is. Talking about ideas over Zoom or somewhere else, where it's talking about as a body, as a physical body in a physical space. Well, yeah, metaphysical space, should we say? Because the building's sort of physical, but space is somehow metaphysical, isn't it? The importance of having that conversation in here with the smell and the texture and the warmth of it, and feeling
the quality of light,
and feeling the form of construction, even feeling the sequence of construction in those corbels and the load path, the human being that made it. Yeah. That was important to me. So that, I guess that's all I was here, is that I've had some funny experiences of people writing about it or making judgments about it who haven't been here. I think that's a funny thing, isn't it? In a world where that increasingly obviously happens now, inevitably. That's not good or bad. It's just a fact.
Yeah.
It's nice to bring it back sometimes, just to that really simple, embodied experience.
Ending on moving forward, what what does the future look like in terms of...
The future is Cork. What does the future look? It's all about the past, Bill. Yeah, we've had lots of, obviously, over the last few years about scalability and what we're doing with Cork now and stuff. And it's sort of, as one would imagine, slightly moved on from that.
Yeah.
Although, into other materials and how they work, and stone works and aluminium. I'm quite Catholic in that sense. That's the other thing I think that the life cycle approach gives you, in the thinking about the relationship between buildings as artifacts, the layer of human systems that feeds into those buildings, and then the layer of earth systems which feeds into the human system, thinking about it in those terms. What can be simplistic, slightly binary conversations, around certain materials at the moment in the industry. Yeah, I think they call it materially agnostic.
Okay. That's nice.
Just so that we're doing this in this. We're just now. This press day today for Chelsea Flower Show next May, and we're doing a garden there for the National Autistic Society, and obviously our involvement really is around the corkiness of it, and the sustainability. But also there are bits of reused stone in the project. There's aluminium, recycled aluminium, which is dyed with plants. There's a coir, again mechanically bolted, a coir frame system. There's a coir mechanically fixed boardwalk system. In terms of renewable and non-renewable materials, as I say, I'm pretty agnostic. So for me, it's about developing an architecture now which responds to that broader understanding of the relationship between natural ecosystems and building life cycles, I guess. And obviously none of that would have come about, obviously, as I said, from 2013, without Cork House, yeah. So that's the future of Cork House. It's definitely not about Cork. we diagram it. When I worked with Oliver, I tell you, we write about it, but we also started diagramming a lot. So I like doing these sort of funny, quite layered or overlapping, interlocking circles and cycles, and then within that, those sit within a geographical context of local to the regional to the global, and they also have an element of deep time built into them, don't they? So, some of those systems, like the biosphere, is probably around roughly human lifetime in terms of plants and trees and so on, but then stone is, millions of years, isn't it? And then the soil is interesting. That has a time scale, doesn't it? If you're making with mud or, so just I think that's a really, and there's no, and what's nice about it, there is no simple way of making an easy decision about it. It's just a really lovely thing to sort of work with and understand, and then how those things are brought to those different materials and time scales and ecosystems out there in the hinterland of your thought, how they come together to form a physical object for 60 to 100 to 500 years. How rich is that? What a way to spend a day.
So good. Big thanks go to Mathew for sparing the time to talk and for the depth and honesty he was willing to speak with. It was really, really appreciated. I hope you enjoyed that as much as I did. Check out the show notes for links featured in this episode. If this was your first episode, then make sure you subscribe. You've got 109 other episodes to listen to, and make sure you don't miss any future episodes. Also, if you've enjoyed this, then please do take 2 seconds to share the episode to your favorite social media. It's really appreciated. And the more people we can have listening, the more people are going to build with these beautiful bio-based materials. Let's collectively inspire really excellent change. A reminder to send in topics for the Christmas podcast. That I am happy for you to throw in anything for that. Yeah, all right, anything. Patreon, if you find this podcast useful or entertaining or something else, then please do consider supporting via the Patreon. The link is patreon.com/building sustainability, and you get yourself 12 hours of bonus content. And if you want to support by £5 or more a month, then I will hand carve you a wooden spoon that you can eat your breakfast with. So yes, patreon.com/building sustainability. And finally, if anyone is still listening, I'm actually going to be selling some of my wooden wares on my Instagram in hopefully the next few days. I just need to get the time to photograph everything. So keep an eye out for that. Grab yourself a bit of wooden stuff. There's bowls and there's cups, and there might be a couple of spoons. Not sure yet. So that's it from me. I am wishing you all the very best. I hope that you're doing so well, and I look forward to speaking to you on the next episode. All the best.